Welcome to a video taking a look at surds. In this video we're taking a look at rationalising the denominator. So just to refresh our memory from the last video, a surd is simply a square root that doesn't go to a whole number, and surds are generally irrational numbers. Now in maths it's a convention to avoid having an irrational number on the bottom of a fraction. So for example, 2 over root 5. Root 5 is a surd and it's an irrational number. We don't want to have that root 5 as the denominator of our fraction. So what can we do to avoid this from happening? Before we think about that, what I'd like to think about is just some basic fractions. Here we've got a half. Now if I multiply this half by, say, 3 over 3, that's going to give me 1 times 3, 3 over 2 times 3, 6. Now what we should see is that a half is exactly the same as 3/6. All that I've done is I've just made an equivalent fraction. 3/6 is the same as 1/2. Now if I do this, say, with 3/5, and this time I'll multiply it by 4 over 4. Here I get 12 over 20, and again what I've got is what we call an equivalent fraction. Now let's do the same with a quarter, 25 over 25 this time. Here I ended up with 1 times 25, 25 over 4 times 25, 100. And this fraction here is exactly the same as this fraction here. I'm just using different numbers to express it. Now why does this work? Why is it that I'm multiplying my fraction here and getting another fraction that is identical but just uses different numbers? Well, it's to do with the fact that what we're actually doing to our fractions here is we're just multiplying them by the number 1. 3 over 3 is 1, 4 over 4 is 1, 25 over 25 is 1. And when we multiply something by 1, it just stays the same. So, let's extend that idea to our original example. Here we have got 2 over root 5. So what I could do here is I could multiply 2 over root 5 by root 5 over root 5. Just taking the surd that is on the bottom of my fraction and multiplying it by that surd over that surd. Now we remember that this is 1, and this is going to give us an answer that is exactly the same as 2 over root 5. Well, 2 times root 5, that's going to give me 2 root 5. And then root 5 times by root 5, that's going to give me root 25. And so I can then simplify this further. Well, I know that the square root of 25, is simply 5. So what I end up with is 2 root 5 over 5. What I've done here is I've ended up here with a number that is a rational number. It is not a surd like we had here. So this relies on the fact that, and we talked about this last time, that root a multiplied by root a is equal to a. Root 5 times by root 5 is equal to 5. So let's take a look at a few examples here. Here I've got 1 over root 7. What I'm going to do to rationalise this denominator is to multiply it by root 7 over root 7. When I do this, I get 1 times root 7, which is going to leave me with root 7, and I've got root 7 multiplied by root 7, which gives me root 49, and then I can say that root 49, well, that is the same as root 49 is exactly the same as 7. Here I've got 2 root over root 11 multiplied by, and I'm just going to take that denominator again, root 11 over root 11. So 2 multiplied by root 11, that gives me 2 root 11. And then root 11 multiplied by root 11, using that rule that we talked about just a moment ago, that's going to give me just 11. Let's take it on to the next one. Here I've got 20 over 2 root 5. In this example, I'm going to still just multiply by the surd that is on the bottom. That's what I'm trying to get rid of. That's what I'm going to multiply both the top of my fraction and the bottom of my fraction by. So I'm not going to multiply by 2 root 5. I'm only multiplying it by the surd on the bottom. So now I've got 20 multiplied by root 5. Well, that gives me 20 root 5. And then that's going to be over 2 root 5 multiplied by root 5. Well, that is going to give me 2 multiplied by root 5. Remember that 2 root 5 just means 2 times root 5 times by root 5. Now, what does that mean? That means that I end up with, on the bottom, 2 multiplied by root 25, which means that on the bottom I end up with 2 multiplied by the square root of 25, which is 5. So on the bottom I just end up with 10, and then on the top we've still got 20 root 5. Now there's one more thing that I can do here. I can actually cancel this fraction down a little bit. I've got 20 root 5 over 10. So basically I can ask myself, well, what number fits into both 20 and into 10? 10 fits into both of them, so I can divide through by 10. And so what I end up with is 2 root 5 as my final answer. Next one, I'm going to multiply it by root 7. So multiplying it by the surd that is in the denominator over the surd that's in the denominator again. When I do this, I end up with 3 root 14, because the root 2 multiplied by the root 7 is going to give me root 14, over, then I've got root 7 times by root 7. That gives me root 49. Well, that's the same as 7. So I've got 4 multiplied by root 7 times by root 7, which is 7. And so now what I end up with is 3 root 14 over 4 times 7, 28. And that would be my final answer. Okay guys, what I'd like you to do is to pause the video at this point, attempt these 4 questions, pay particular attention to this one at the bottom. It's quite a nice example and it employs all of the stuff that we've learnt about surds so far. So pause the video at this point, try these examples on some paper. What you'll find is that this will help to cement your understanding if you do this. Then when you're ready, press play, and then the answers are coming up. So here are the answers to those practice questions. Like I say, this one at the bottom is quite a nice one. Goes on for quite a while, and hopefully you can follow through what has happened here using everything that we've learnt so far.